Hoy crearé oraciones de libros. Comencemos. Estas oraciones de inglés son para los que hablan en inglés puedan entenderlas. Son algunos ejemplos.
The moon is Earth's only natural satellite. It's the satellite that regulates the tides. I think we've eliminated you and will put you to bed. Subscribe to our channel, give us a like, and leave us a comment to see any part of this video that interests you. See you in the next video.
Ahora
Here's the answer to what is the moon with questions, exclamation points, answers, ask me, including quotation marks, 1 quotation mark, 2 quotation marks, and when you say something. A proper noun is on the moon, say it in quotation marks and say it all around, and you also have to say a semicolon, 5 questions, questions and exclamations, all together in one long paragraph. What is the moon? The moon is Earth's only natural satellite. It is so bright at night. Its brightness is due to it reflecting light from the sun. How is this natural satellite formed? The moon is believed to have formed as a result of a huge impact between the early Earth and a body the size of Mars. It's huge, isn't it? Its diameter is approximately 3,474 kilometers, which is considerable. Did you know that Neil Armstrong was the first person to set foot on the moon? Yes, Neil Armstrong was the first human to walk on the moon on July 20, 1969. During the Apollo 11 mission. What an incredible achievement. Everyone looks at it, it's there all the time. Everything we know about it is fascinating. Is it Earth's only satellite? Yes. The moon is our planet's only permanent natural satellite. What a mystery. All of this is astonishing. It all seems so far away. A whole world waiting to be explored. What is its influence on the tides? The moon exerts a strong gravitational influence on Earth, being the main cause of ocean tides. It is so important for our planet.
yeah.
Here are 10 consequences of the moon getting closer to Earth, with detailed explanations in English. Here are 10 consequences of the moon getting closer to Earth, with detailed explanations in English. Extreme tides. The most immediate and dramatic effect would be a massive increase in tidal forces, leading to catastrophic flooding and erosion in coastal areas. Can you imagine waves hundreds of feet high? Tides would reach unprecedented levels, both high and low. drastically reshaping shorelines and impacting marine life. Increased volcanic activity and earthquakes. The stronger gravitational pull could exert immense stress on the Earth's crust, resulting in a significant surge in volcanic eruptions and earthquakes across the globe. Think of the widespread destruction and loss of life. This heightened geological activity would pose a constant threat to populated areas. Changes in Earth's rotation. The Moon's current gravitational influence stabilizes Earth's axial tilt, but a closer Moon could cause significant wobbling in our planet's rotation. What drastic climate changes and unpredictable seasons would this bring? This instability could lead to prolonged periods of extreme weather. Atmospheric effects. The intensified gravitational pull might also affect Earth's atmosphere, potentially causing stronger winds, more severe storms, and alterations to established weather patterns in unpredictable and dangerous ways. Imagine the chaos. Could we even adapt to such volatile conditions? Orbital decay and potential collision. As the Moon gets closer, tidal forces exerted by Earth on the Moon would cause the Moon's orbit to decay further, increasing the likelihood of a catastrophic collision in the distant future. How could humanity prepare for such an eventuality? This slow but inevitable spiral inward poses an existential threat. Disruption of ecosystems. The extreme and rapid changes in tides, climate, and geological activity would devastate ecosystems worldwide, leading to mass extinctions of countless plant and animal species. Wouldn't this be an irreversible tragedy for our planet's biodiversity? The delicate balance of nature would be shattered. Night sky changes. The Moon would appear dramatically larger and much brighter in the night sky, significantly impacting nocturnal animals' behavior and circadian rhythms, and profoundly changing human observation of the stars. What a breathtaking, yet terrifying sight it would be. Increased space debris impacts. The intensified gravitational interaction between Earth and a closer Moon could pull more space debris towards our planet, substantially increasing the risk of meteoroid and asteroid impacts. Could our defenses protect us from such threats? This bombardment from space would add another layer of danger. Communication and navigation problems. Satellites orbiting Earth could be significantly disturbed by the Moon's closer proximity and increased gravitational influence, potentially disrupting crucial communication, weather forecasting, and navigation systems. How would society function without these essential technologies? Psychological impact on humanity. The constant threat of extreme natural disasters, the dramatically altered night sky, and the overall instability of the planet would likely have a profound and negative psychological impact on humanity, leading to widespread fear, anxiety, and uncertainty about the future. What would become of our mental well-being? What would happen instantly if the sun disappeared? Earth would be plunged into total darkness. There would be no sunlight to light up the day, and the temperature would begin to drop rapidly, turning the planet frozen in a short time. How quickly would it become uninhabitable for most life forms? In a matter of weeks, the lack of light and extreme cold would wreak havoc. What would happen to the orbits of the planets in our solar system? Would they continue to orbit nothing? No, without the sun's immense gravitational pull, all the planets, including Earth, would be shot straight through interstellar space, each in a different direction, aimlessly wandering through the galaxy. What would happen to life on Earth in the long term? Plants would stop photosynthesizing and die, which in turn would lead to the extinction of all herbivorous animals, followed by carnivores. How would humans try to survive? only in deep underground shelters, using geothermal or nuclear power sources for heat and artificial light, but long-term survival would be extremely challenging and likely impossible for most. What would be the ultimate fate of our solar system without its central star? It would slowly disperse into the darkness of space, becoming a cluster of icy, lonely worlds wandering eternally in the cosmic void. Absolutely. Here's a detailed answer about why Andromeda is approaching and why the moon is receding, attempting to incorporate the punctuation and symbols you requested. Though remember that not all sentences will strictly follow this pattern to maintain the naturalness of the language. Why is Andromeda approaching? The majestic Andromeda galaxy, our nearest spiral neighbor, isn't exactly parked in the cosmos. In fact, it's on a direct collision course with our own galaxy, the Milky Way. The primary reason for this cosmic approach lies in the ever-present force of gravity. Andromeda and the Milky Way are the two most massive members of our local group of galaxies, and as such, they exert an incredibly powerful mutual gravitational pull. Astronomical observations, conducted over decades, have provided irrefutable evidence of this approach. Scientists have measured the blue shift of the light emitted by Andromeda's stars, a phenomenon similar to the Doppler effect we observe with sound. This blue shift indicates that light is being compressed as the source, in this case, Andromeda, moves toward us. Precise measurements reveal that Andromeda is approaching at an astonishing speed of approximately 110 kilometers per second. This approach does not imply an imminent collision in human terms. The galactic collision is estimated to occur in about 4.5 billion years. An almost incomprehensible time span. When the two galaxies finally meet, it will not be a collision in the traditional sense. The spaces between the stars within each galaxy are so vast that it is highly unlikely that individual stars will collide directly. Instead, the two galaxies will gradually merge, driven by gravitational tides, to form a larger hybrid galaxy, sometimes referred to as Milkomeda. This process will be a cosmic spectacle of epic proportions, although it will happen on a timescale unimaginable to us. Why is the moon moving away? The moon, our faithful natural satellite, has not always been at the distance we see it today. Nor will it remain that way forever. The main reason for its slow but steady retreat from Earth lies in the complex interactions of tidal forces between the two celestial bodies. The Earth rotates on its axis at a speed greater than the moon takes to orbit our planet. Earth's gravity exerts a force on the moon, creating a tidal bulge on the side of the moon facing Earth and another on the opposite side. Similarly, the moon's gravity also creates tidal bulges on Earth, primarily in the oceans. Due to Earth's rotation, these Earth-facing tidal bulges are not perfectly aligned with the line connecting the Earth and the moon, but are slightly offset. The gravity of these earthly protrusions exerts a small force of attraction on the moon, pulling it slightly forward in its orbit. This small force, although seemingly insignificant, gradually increases the moon's orbital energy, propelling it into a slightly higher orbit and therefore farther from Earth. This drift has been measured with astonishing precision using laser reflectors placed on the lunar surface by the Apollo missions. Scientists send laser pulses from Earth toward these reflectors and measure the time it takes for them to return. These measurements have revealed that the Moon is moving away from Earth at a rate of approximately 3.8 centimeters per year. This process will continue for billions of years, until the Earth's rotation slows enough to match the Moon's orbital period. At that point, the Earth and Moon will be tidally locked, always showing the same side to each other, and the drift will cease. This distant future presents a very different scenario than the one we know today, with much longer Earth days and a Moon that will appear smaller in our night sky. I hope this detailed explanation has answered your questions satisfactorily, incorporating the requested punctuation and symbols where possible for a better understanding. The universe is a fascinating place full of constant movement and change. The beginning of the cosmic earthly descent, drilling the crust. Imagine our advanced ship, the Star Drill, with thermonuclear shielding and ion propulsion, beginning its epic descent from the Earth's surface, a remote point shrouded in mystery. The first, crucial and challenging stage would take us through the Earth's crust, the outermost layer. Relatively thin but resistant, its thickness varies considerably, being thinner under the vast oceans, approximately 5 to 10 kilometers, and thicker under the towering continents, around 30 to 70 kilometers. As we advance, the initially moderate temperature would begin to rise perceptibly. The surrounding rocks, composed of granite, basalt, and other geological formations, would progressively heat up, indicating increasing geothermal energy. Pressure, a determining factor in our journey, would increase exponentially with each meter descended. We would endure a colossal, crushing force that would test the limits of our technology. Our ship, equipped with state-of-the-art plasma drills and sophisticated cooling systems based on liquid helium, would slowly penetrate this rocky layer. We would be able to observe, through reinforced sapphire crystal windows with multiple protective layers, the diverse geological formations. Sedimentary strata, veins of glittering minerals, such as quartz and pyrite, and perhaps even find pockets of superheated groundwater with unimaginable pressures. The Earth's intense mantle, navigating among viscous rocks. After crossing the Mohorovičić discontinuity, the MOHO, the critical boundary between the crust and the mantle, we would enter the Earth's extensive mantle. This massive layer extends to a depth of approximately 2,900 kilometers. Here, temperatures reach extreme levels, between 500 degrees Celsius and 3,000 degrees Celsius. And the pressure becomes simply overwhelming, millions of times surface atmospheric pressure. The rock, although seemingly solid, behaves like an extremely viscous fluid on geological timescales, flowing slowly under the immense pressure. Our ship, designed to withstand these extreme conditions, with tungsten and titanium alloys, would have to navigate carefully through this ocean of hot, dense rock. We would possibly encounter convection currents, where warmer material rises and cooler material descends, similar to ocean currents but much slower and more powerful. We might observe, albeit with difficulty due to the density of the material, the presence of exotic minerals, such as olivine and peridotite, and traces of ancient volcanic activity, such as solidified magma vents and extinct magma chambers. The liquid metallic heart, the boiling outer core, reaching a depth of approximately 2,900 kilometers, we would enter the outer core, This fascinating layer is a sphere of liquid metal, composed primarily of iron and nickel, with traces of other elements, with temperatures ranging between 4,000 degrees Celsius and 5,000 degrees Celsius. The turbulent motion of this conductive liquid metal is responsible for generating Earth's magnetic field, our protective shield against space radiation. This dynamic phenomenon creates massive electric currents and intense magnetic fields. Our craft, protected by advanced electromagnetic fields, would have to maneuver through this sea of molten metal. We would experience powerful magnetic forces and the sensation of being immersed in a gigantic natural dynamo. We would be able to observe, through specialized sensors, the complex convection currents and perhaps even the formation of metallic waves and eddies, similar to storms in Jupiter's atmosphere. The solid and mysterious center, the inner core. Finally, after an incredibly challenging journey, we would reach the inner core, a solid sphere of iron and nickel, with a radius of approximately 1,220 kilometers. Although the temperature here is still higher than in the outer core, around 5,500 degrees Celsius, the extreme pressure, approximately 3.6 million times the surface atmospheric pressure, compresses the metal atoms so tightly that they form a solid crystalline structure. At this central point, we would experience slightly less gravity than on the surface. Due to the distribution of the surrounding mass, darkness would be absolute, and we would be surrounded by a glowing metal sphere. A testament to the fundamental forces that shape our planet. This solid core, although seemingly static, plays a crucial role in Earth's internal dynamics. Subscribe to our channel, give us a like, and let us know in the comments to see any part of this video that interests you. See you in the next video.